Today I'm going to be talking about recreating an analog effect in Blender's compositor nodes. This is in Blender 4.5. You're going to have to use this version because there are some nodes that I use, like the new noise texture node. Also, if you're interested, I have already done a node group. You can see on the screen, it's called Analog Video Effect, and it's got a whole bunch of options, different things you can play with and things you can tweak to get the kind of level of analog degradation in your digital image. So if you are interested, you can go down to description. It's on my Gumroad. It's $2. So yeah, there's that there. Otherwise, I'm going to get into talking about the effect and how you can create it yourself in Blender. So there are 5 things I'm going to be doing in this tutorial. I'm going to be doing a blur and sharpen pass to reduce initial detail. Then I'm going to do chroma bleeding, basically trying to recreate the low resolution and sometimes misaligned color channels in your analog recording. I'm going to be adding some noise, some black and white and some color noise. And then I'm going to add some horizontal wobbling. You think about how tape goes through a VCR, it might move kind of left from right, and you might see that in your analog recording. And then one last blur pass and a desaturate pass, but done a little bit more cleverly, so you're only bringing down the most saturated parts of your image. So to start with that blur and sharpen pass, press Shift A, search for a node. You can search for the blur node. Set it to fast Gaussian. At this point, fast Gaussian is nearly as accurate as Gaussian. And I'm going to use a horizontal blur, a little bit more than the vertical. So 9 pixels on the X, 5 pixels on the Y. And then Shift A again to add in a filter node. And you can see there's 2 you can use here for sharpening. There's box and diamond. Diamond is quite moderate. We want quite a strong sharpening effect here to kind of remove that fine detail. So I'm going to set this to a factor of 0.4. I'm going to select them, press Shift P to put them into a frame, and then you press F2 to rename that frame. I'm going to call that blur and sharpen. So moving on to the next effect, or next part of the effect, we're going to be doing the chroma bleeding, where we blur and then displace the color channels. So first, to get access to those color channels, we want to separate color using a separate color node. And I'm going to set it from RGB to YUV. YUV was the analog color space used. And to then get that image back, we can then use a combine color. Again, set that back to YUV. And if we connect up the U and the V channels, you see we get back to the original image. If you have alpha in your image, you can also connect that. If you have any transparency. If you're confused about what these actual channels mean, Y was the black and white image or the luminance, and the U and V channels were the color channels. So we want to distort the U and the V channels. So Shift A, add another node, add a blur node, then drop that onto the U channel. And if you press Shift D to duplicate that, you can drop that onto the V channel. And I've left these as Gaussian, but you can use fast Gaussian if you want, or really any blur method that you like. I'm going to do quite a strong blur on the horizontal, so 12 pixels on the X this time, to kind of smear the colors across horizontally. Then Shift A again to add a displace node. Shift D, and put that after the blur node. And we can use this to basically shift the colors by a fixed amount of pixels. I'm going to do quite a large amount, so it's quite obvious in the video. You can see how, especially around the balloons, where those bright saturated colors have been pulled off the balloon to the right. If you have a look at the left side of the balloons, you can see where the background, for example, of the wall has bled into that. So I'll just tidy these up a little bit, and then I can add them into a frame again. So select all the nodes, Shift P, F2 to rename, and I call that chroma bleed. On to the next part of this effect, which will be adding noise. So I'm going to start by adding black and white noise first. So if you search for a noise texture, this is new in 4.5. These are the same ones from the shading workspace, but now you can use them in the compositor. I'm going to set that to 4D, add in a brightness and contrast node. And if I just connect the factor to the image, and then the image to our viewer node, you can see what this noise texture is, and then what this brightness and contrast node does. So by turning down the brightness, you increase the contrast. And that's what we want. We want a black and white image that we can overlay onto our original. So I'm going to turn the scale, the detail, and the roughness up quite high, because we do want a very detailed kind of noise that we can overlay. And now what I need to do to manipulate how that noise overlays is add in the new node, the image coordinates, and use uniform, which is the default. But while that changes nothing, we can then put in a vector math node and drop that in, set it to multiply, and then we can actually, by setting the x and the y of that vector back to 1, we get the same image. But if we play around with the x and y values, you'll see how it distorts how that noise appears. So if we set the x to something really, really low, it stretches it horizontally, and we set the y to something much higher, it kind of squashes it vertically. And we get a really nice horizontal noise. I'm going to clamp that value between 0 and 1 because we don't want anything higher than white and nothing lower than black here. Shift A, search for a mixed color node. Drop that in and set it to add. And if we hook up our noise to the B slot, you can see that we're adding this noise on according to this factor. So if you want lots of noise, set it to 1. If you want very little noise, you set it to a very, very low value or turn it off completely with 0. I'll leave it quite strong for the video. If you want to animate this noise, we can use a driver. A very, very simple driver. Hash frame. You just type hash frame into the W value of your 4D noise texture. And then you can actually see, if you then scrub through the timeline, as you can see I'm doing here, I'm adding the timeline back into my compositing workspace. And then if you just scrub through the arrow keys, you can see that the W value is changing with the frame number. So that means every single frame you get a new seed, and the noise is unique per frame, which is how it would be when you were recording it in an analog format. So again, if I tidy all those up, select them all, Shift P, put them into a frame, just keep the workspace nice and tidy. I'll name it something like black and white noise. And because we want to add in color noise after that, I'm actually just going to select all the nodes. I'm going to copy and paste them so we don't have to add all those nodes back in. And then I'm just going to tweak them a little bit from there. So if we hook our output from the previous effect back into the A slot of our mixed color, we can then mess around with some nodes. We don't need to clamp this noise, and we don't need to change its brightness or contrast. So I've also reset the vector math here back to 1, 1. I need to make sure that normalize is disabled here. So you're getting like a full range of colors that you can overlay. I'm going to turn the scale and the roughness down to kind of get a soft kind of noise. And you can play around with the scale to get it to something that you like. And again, the color channels in an analog format, like tape, for example, videotape, would have been quite low resolution. So with the noise. So we can do Shift A and add in a blur node, and we can actually blur that noise. You could also decrease the detail, but I find that setting it to a higher detail and then blurring it gives you just a little bit more kind of artistic control. In this case, I'm blurring it again more horizontally than I am vertically. So this is a very, very strong effect. So I think I set it to 0.02 here, 0.01, something very, very low. Again, as before, we can use the same trick of using hash frame to animate our noise texture, so we get a new seed every frame. So again, tidy those up, select them all, Shift P, put them in a frame, and then we can move on to the next effect, which would be the horizontal wobbling. So this is trying to recreate how when tape goes through a VCR, a video player, because it's a physical tape, I have to move through a physical like scanning or reading mechanism. I'm not entirely sure how it would work. The tape would move kind of left and right. It wouldn't be 100% aligned every time. And so by, again, using a noise texture and manipulating its coordinates, as you can see I'm adding in the coordinates here, we can distort this noise texture and use it as a mask to displace our original image. So I'll show you how to do this. I'm going to add in a vector math again, set it to multiply, and this time I don't really mind about squashing it vertically, but I want to stretch it really far on the X. Basically get kind of like a wave texture. You could use a wave texture here, but I find that for getting more variation, a stretched noise texture is better. You can play around the different sort of values here in the noise texture to get a different look. Okay, so we do Shift A, we add in our displace, and then we can drop that in. We need to have something that can drive the X scale. So I'm going to just increase the contrast of this image. So I'm going to sort of darken and lighten both ends by dragging in each side of the color ramp, and you see you get darker black lines and lighter white lines, which just makes the kind of distortion effect a little bit more obvious. Now currently, this noise texture is outputting between 0 and 1. We need to change that between -1 and +1. So then we can distort the image left and right rather than just to the right. So you do some maths here, subtract 0.5, multiply by 2, you then get to -1 to 1. And now we've got our mask. If you add in another math node set to multiply, you can control the strength of this distortion. So I set it something quite high here, and you can see the effect it has. So 1, it's quite a subtle effect. But remember, when we animate this, a subtle effect is usually much more preferable to a large effect because it can make the whole image horrible to watch. So to animate this, we need to add something into our vector every frame. So if I just get the mask back, you can see if I change the X value, you kind of distort the noise texture, because you're moving it horizontally, but when you change the Y, you're moving the texture up and down. And that's what you want, because that wobbling would go up the screen as the tape is read through the VCR. So just because we want to only change the Y value, if we add in a combine XYZ node, and then add in a value node, we can turn the value into a driver with the hash frame driver again. And then we can plug that into the Y, and every frame will move 1 unit up vertically, or actually I think it will move one down because you're adding to the Y. Adding 1 to your image is actually quite a lot. So if we divide this value by something big, we can see the effect a little bit better. So here we go. So now, if you scrub through the timeline, you see it moves down. If you make it negative, you'll see that the mask will move up, which is what I want. So if I just divide it by -10, you can make that a little bit for like a faster animation. And I've animated the mask moving. We can then go back and plug that in and see how that looks. So if I scrub through the timeline, you can see now that the wobbling is animated. Every frame, that effect moves up. However, if we increase it by a lot, you'll see how the image distorts from the edges and you get left with these transparent gaps. It's kind of a really cheap trick you can do to get around this is by using an in-paint node. An in-paint node will basically fill in any gaps in your image with the pixel color that's closest to it. So while it's not amazing, if you're using a really, really strong effect, it can just fill in those gaps so it's less obvious. So again, add them all into a frame. I think I call it horizontal wobbling or horizontal wobble. And then we can add in one last thing. We need to add in a blur pass again, because as you can see, that noise is very, very fine detail. The noise, as everything in analog, would have been much lower resolution. So if we do a basic, just another blur, a fast Gaussian blur, you see how that noise then becomes, it doesn't feel like the noise is being overlaid directly on top of the image, it feels like it's now part of the image. And you'll see that the balloons, for example, are really, really saturated. In old analog video, the colors wouldn't have been so saturated, they wouldn't have actually quite muted, because a lot more information is dedicated to the black and white of the image than it was the color, because there's only so much you could fit in terms of information in those old analog formats. So if we separate color, but this time we do HSV, so hue, saturation, and value, and you recombine it, we now have access to the saturation channel of our image. If we throw in a float curve, you can actually manipulate the saturation of your image using a curve, which means that it gives you full control over something that's very, very saturated and something that's not very saturated. And so what we want to do is we want to bring down the most saturated parts of our image without affecting kind of like the middle values and the low end values. And so if you throw another point in here, and you can straighten it out to keep the less saturated areas of your image the same, and then you can just turn down the saturation on the most saturated parts of your image. You can see the balloons are now much more muted in color, which is much more accurate to the analog format. That's our blur and desaturate pass. This is kind of like the last part of it. And there we have it. So that is sort of like DIY analog video effect. It's not as comprehensive as something like DaVinci Resolve's effect, for example. It also doesn't exactly cover everything that I've put in my node group. Again, if you're interested, there's some extra bells and whistles in there, but it is based off of this effect.